In a sudden and disquieting turn of events, 4 of the world's most advanced space telescopes operated by NASA and international observatories have simultaneously recorded a dramatic drop in brightness from the interstellar object 3I SOG's Atlas. This isn't just another dimming comet, it's a potentially history-defining anomaly. Within just days, the object went from a steady glowing presence to an eerily fading specter in space. What's even more unsettling, the change occurred across multiple wavelengths, visible infrared ultraviolet, making it virtually impossible to dismiss as a glitch reflection error or atmospheric interference. This is real. This is happening.
Yes,
And this shift in luminosity is so consistent, so abrupt, that it's triggered an alert inside NASA's Deep Space Monitoring Network. Is this a natural evolutionary phase of an alien comet? Or something far stranger, a coded signal from a foreign system? The object in question, dubbed 3I Atlas, was first detected in July 2025 by the Atlas Survey in Chile. From the beginning, it puzzled astronomers. It wasn't just hyperbolic in trajectory, confirming it came from outside our solar system. It also appeared chemically distinct. Its coma, the glowing cloud surrounding its icy nucleus, displayed an unusually high concentration of carbon dioxide compared to water vapor, something not typically seen in comets native to our system. Still, nothing hinted at instability. It glided smoothly past the outer planets, emitting a consistent glow until now. The sudden dimming has launched a storm of theories among planetary scientists. Could this be an exhaustion of volatile compounds? A thermal rupture caused by solar proximity? Or is this object entering a phase transition we've never witnessed before? The timing couldn't be more critical. As the object continues its flyby toward Mars, its behavior grows increasingly erratic. Some scientists argue this isn't simply fading, it's a hostile transformation, a shift in reflectivity, a cloaking of inner activity, perhaps even the collapse of its surface structure. Harvard astrophysicist Dr. Amir Qadri has gone further, warning that if this event involves exotic ices or radiation-induced phase change, we might be staring at the breakdown or birth of something beyond standard cometary physics. And here's where it gets truly bizarre. Among the data flooding in from Hubble Webb and Swift, there are signals consistent with the formation of complex carbon chains, organic molecules that could hint at prebiotic chemistry, or worse, artificial material. Could 3I Atlas be something more than a rock and ice relic? Is this the final act of a disintegrating interstellar traveler, or the unveiling of something concealed until solar activation? The implications are enormous. We've only seen 2 other interstellar objects before, Oumuamua and Borisov. One tumbled mysteriously, the other behaved more like a traditional comet. But 3I Atlas, it's rewriting the rulebook in real time. And it's not just astronomers watching anymore. The Pentagon and international space agencies have reportedly been briefed. Because if this darkening is more than a natural decay, if it's deliberate reactive, or signals a concealed state, we could be witnessing the first active behavior of an object not born under our sun. It's not just fading, it's changing, transforming, maybe even hiding. The real question is, what exactly is 3I Atlas preparing for? The scientific response to the dimming of 3I Atlas has been immediate and intense. NASA has reallocated observational resources across multiple missions, instructing both Earth-based observatories and spaceborne instruments to begin continuous tracking. The James Webb Space Telescope, JWST, known for its precision in detecting faint infrared signatures, has been tasked with identifying whether the object's spectral fingerprints are shifting, an indication that its chemistry is actively changing. Initial infrared readings have shown a significant reduction in the emission of water vapor, while carbon dioxide lines remain strong. That's not just odd, it's unprecedented. In most comets, as they approach the Sun, water sublimation increases. But in this case, water appears to be vanishing faster than expected, while CO2 remains dominant, suggesting either a sealing of subsurface ice or a radical compositional imbalance. The Hubble Space Telescope has confirmed this drop in brightness is not uniform across all light bands. In particular, ultraviolet reflection has fallen more steeply, indicating the outer coma may be thinning or collapsing inward. Meanwhile, the Mars Reconnaissance Orbiter, which had previously captured peripheral data as the object passed near Mars's orbital path, is being retasked to capture additional imaging in hopes of identifying any structural changes. Experts at NASA's Jet Propulsion Laboratory and Goddard Space Flight Center are modeling possible scenarios. One involves the formation of an insulating crust on the comet's surface dust and non-volatile compounds accumulating quickly and blocking sunlight from reaching the volatile layers below. Without sunlight, penetration, sublimation would stall, and the coma would effectively shut down, making the object appear to dim. But other hypotheses are darker. Some suggest we may be witnessing fragmentation beneath the surface. If the nucleus is experiencing internal cracking, due to thermal gradients, one side superheated by the sun, the other in shadow, it could be venting gas through internal cavities before collapsing and sealing again. This intermittent activity could cause the observed erratic light behavior. Another team proposes that complex polymers, known as tholins, may be forming on the surface. These dark, tar-like compounds are the result of cosmic radiation acting on organic molecules over eons. They absorb visible light exceptionally well, giving distant bodies a red or brown hue. Their sudden presence would explain the color change noted in recent photometry reports and the object's increasingly hostile visual signature. Compounding, the mystery ground-based telescopes in Chile, Hawaii, and Spain have all reported faint polarization shifts in the scattered light. Subtle changes in how light is reflected, often caused by a change in dust particle size or shape. This suggests that the particles surrounding 3I Atlas are aggregating or clumping, possibly due to electrostatic effects or a reduction in outgassing pressure. In simple terms, the object is not just dimming, it's behaving like a system in transition, one that is shedding sealing or possibly even reorganizing its own structure. NASA has elevated this object from observational interest to active monitoring priority. What comes next, flare collapse or silence, will determine whether 3I Atlas remains just a scientific curiosity or something far more. As 3I Atlas plunges deeper into the inner solar system, the scientific tension around it has escalated to a near fever pitch. What began as a curious object of study has turned into a cosmic wild card, behaving in ways that defy both expectation and explanation. The coordinated dimming across 4 independent telescopes isn't being treated as a passive event. It's now a trigger for full-scale investigation, and for good reason. The comet's behavior is violating the assumptions baked into decades of planetary science. Theories are now competing for dominance, and each new dataset only adds fuel to the debate. One prevailing hypothesis suggests that 3I Atlas is undergoing a catastrophic surface collapse, one that has cloaked its reflective halo in a dense layer of non-volatile dust. This would explain the muted brightness across all bands. But a competing theory is even more provocative, that the object is not dimming due to collapse, but due to transformation. In this view, sunlight, after potentially billions of years in darkness, has triggered rapid chemical reactions in the surface layer, leading to a dark organic crust. It's a known process in outer solar system bodies, but never observed in real time on an interstellar visitor. This layer could act like a thermal insulator, altering sublimation rates and shielding the inner nucleus. Essentially, this could be growing a skin one that makes it harder to read, analyze, or predict. But even more intriguing is the possibility of internal activity. Recent radio observations have hinted at irregular emissions from common cometary molecules like carbon monoxide and cyanide radicals, compounds typically released in regular pulses. But in this case, the signal is inconsistent. This suggests either rotational variability or internal trapping and release of gases through structural fractures. And here's where things get strange if the object is tumbling, as many suspect. Its active regions could rotate in and out of sunlight, periodically venting before freezing shut again. That would create the erratic brightness pattern we're now seeing. Yet the frequency and consistency of the dimming don't quite match this explanation, leading some researchers to propose a more radical idea that the object is releasing material directionally. In other words, it's venting jets that are not aimed toward Earth, creating an asymmetric coma that only appears dim from our vantage point. This has triggered speculation that 3I Atlas may have structural complexity. Vent channels, layered cores, or anisotropic thermal conductivity characteristics that would imply it's far more than a loose ice ball. Could this be evidence of a differentiated interior with zones that heat and respond independently? If so, it challenges the view of interstellar comets as primitive. It would imply that some interstellar bodies have evolved chemically or structurally while drifting for eons through galactic space. And now, new ultraviolet readings are adding another layer to the puzzle. The decline in UV reflectance has outpaced the drop in visible light, suggesting that the comet's surface material is selectively absorbing high-energy photons. That's a strong indicator of complex organics or carbon-rich residues compounds that are not only dark, but chemically active under solar irradiation. This isn't just fading light, it's reactive matter. Meanwhile, inside NASA and the European Space Agency, internal discussions are shifting toward how to interpret these readings, not just scientifically, but strategically. If 3I Atlas represents a class of darkening, fast-evolving interstellar bodies, then our detection models may be fundamentally flawed. We may be missing dozens, perhaps hundreds of similar objects every decade, simply because they cloak themselves too quickly. The implication: the galaxy may be full of such travelers, passing silently between stars, shedding light only briefly before vanishing again into the dark. The stakes of understanding this one object are enormous. Each fading photon carries data about temperatures, materials, radiation damage, and sublimation chemistry. It's a diagnostic tool delivered from a star system we've never seen. And if we misread it, we may lose a chance we'll never get again. So the tension continues to rise, because the longer 3I Atlas dims, the deeper the mystery becomes, and the less time we have to solve it. In the waning days of its visibility, 3I Atlas is slipping from the watchful gaze of our most powerful instruments. Yet paradoxically, it's growing more significant with every passing hour. What we are witnessing is more than just the evolution of a comet. It's the disintegration of certainty. Scientists are now openly debating whether this darkening marks the end of the object's active life or the beginning of a new state altogether. Some argue that we're seeing the natural expiration of volatile reserves, a comet aging in fast motion, exhausted by its first exposure to starlight in perhaps 1 billion years. Others contend the story is far from over. They point to subtle flickers in the light curve, tiny fluctuations that may signal internal pressure building toward a sudden outburst. If such a flare occurs, it could eject crustal layers and reignite outgassing, offering one last glimpse into the hidden interior. But if that moment never comes, and the dimming holds, then this may pass silently into the void once more, an emissary swallowed by its own alien chemistry. Either outcome would rewrite how we approach future interstellar objects. Already, NASA's planning teams are revisiting the objectives of the proposed Comet Interceptor mission, with a new emphasis on early spectral detection and flexible response capability. Because if we've learned anything from this fading visitor, it's that time is not on our side. The object taught us how volatile rich bodies from other star systems might evolve rapidly, darken quickly, and challenge our most refined instruments. It has forced astronomers to question whether most interstellar objects go unnoticed. Their brightness curves too fleeting, their chemical signals too strange. More importantly, it reminded us that the cosmos doesn't wait for us to be ready. 3 Atlas was not invited. It appeared unannounced, revealed secrets in its dimming, and may now vanish forever. But in that brief encounter, it gave us a rare message etched not in words, but in photons. A message that says the universe is older, stranger, and more reactive than we dared imagine. And our place in it is as much about paying attention to the shadows as chasing the light. As the final observations roll in, one question lingers, one that no model telescope or simulation can yet answer. What did we just witness? Was it the slow death of a comet, or the silent signal of something we've never seen before?